Hi guys, welcome to our video lecture series of Laplace transforms. So today we will talk about a new topic, that is convolution theorem. Convolution theorem, and remember that we are discussing about the inverse transforms. So convolution theorem is an important topic of the inverse transforms, and we will talk about convolution theorem, and we will see that how to use convolution theorem to solve for inverse transform. So what actually the convolution theorem says? So the convolution theorem says that if f of s and g of s are the Laplace transforms of f of t and g of t, f of t and g of t respectively, then f of s and g of s is the Laplace transform, of the integral 0 to t f of t minus u multiplied by g of u du. So this is the convolution theorem basically. So we will take some examples on convolution theorem to make concepts more clear, and then we will see that we can use these convolution theorems in the part of differential equations, solving differential equations. So first of all, let me take an example for this. So let's say that we have to find the inverse transform of s over s squared plus a squared whole squared. Now, so we have to find the inverse transform of this function. So now I can say that I can break this function. This implies that I can break this function into some form like s over s squared plus a squared, that is multiplied by 1 over s squared plus a squared. So now I have broken this problem into two functions of s. The first function is, say, f of s, that is s over s squared plus a squared, and the second function is, say, g of s, that is 1 over s squared plus a squared. Now we can see that these functions are basically the inverse transforms. These functions are basically the transforms of cosine and sine. So the Laplace inverse of f of s is nothing but cos of a t, and the Laplace inverse of g of s is nothing but sine of a t divided by a. So now we are approaching towards the conclusion, and we have the function. So now I can write these functions as what the convolution says is, now I can write these functions as convolution cos a t static 1 over a sine a t. Now I can write this function in a convolution, that is 1 over a integral 0 to t, and suppose this is f of t cos a t. So I can write it as cos of a multiplied by t minus u, because I have to replace the function of t with t minus u, and then multiplied by sine of u, that means sine of au and du. Now I have to integrate this function to find the inverse transform, and the integral of this function will be the inverse transform of this function. So I have to integrate this function, and I will apply, first of all I will use trigonometric identities to simplify, and then I will apply the integral to this equation. So now I will simplify this with a trigonometric identity. So I will get cos AT multiplied by cos AU plus sine AT multiplied by sine AU, and that is multiplied by sine of AU du. Now we have to integrate this function, and so to do that we have to simplify it. We can simplify it like we will 1 over a is common in all, then I can take cos AT, cos of AT, and I missed one thing, that is okay. So now I can write cos AT outside. I can write cos AT outside. So what I will left with the in the integral is 0 to t cos AU sine AU du, then plus I can put sine AT out, and I can write 0 to 2 sine AU multiplied by sine AU du. Now we'll simplify it further. Now look at this part. This is cos multiplied by sine. So if I multiply it by 2, I will get sine 2 theta. So sine 2 theta. So to multiply 2, I will divide it by 2. So it will be 2 cos AU sine AU, that is sine of 2 AU du, plus sine AT will be as it is, and again this is sine square AU. So sine square AU is 1 minus cos 2 AU divided by 2 du. Now the integrals are simplified, and now I can apply the integral. So when I integrate, you can integrate this function using your own way, so it's easy, you can proceed, and I am writing it directly here, that is cos of AT divided by 2 multiplied by minus cos of 2 AU divided by 2a, and the limits are from 0 to t, and again plus sine of AT divided by 2 multiplied by u minus sine 2AU divided by 2a, and the limits are from 0 to t, and limits are from 0 to t. Now we are very near to our solution. We are near to the solution. So now when I multiply the functions, what I get is cos AT, and I will apply the limits, cos 2AT plus sine AT sine 2AT sine 2AT, so plus cos of AT divided by 4a squared plus t sine of a t over 4 sorry 2a. It's 2a. And when we'll simplify it further, we will get t sine at t sine at upon 2a, because the things will cancel out, like this cos at over 4a squared will be uh, this is cos at, this is cos at, cos 280 plus sine 80 sine 280, so I can write it as cos of alpha minus beta. So it will be cos of 80 over 4a squared. It will be cos of 80 over 4a squared with the negative sign, so this will cancel and we will left with this function only, that is t sine 80 over 2a. So the Laplace inverse transform of s over s squared plus a squared whole squared is equals to t sine of 80 divided by 2a. This is the final answer, and I hope you understood this part. And convolution is very easy. We have just to, first of all, we have to select the function f of s and g of s. Then we have to apply the convolution using and I will first, the other thing is to identify the function of s, that is the transform of what function. So after identifying that, we will make the convolution and we will put into the integral using the convolution, that is f of t minus u into g of u du. So I hope you understood it well. Thank you guys. I will come with an example, another example, to make the concepts more clear. So before embarking into the differential equation topic, we will be with good concepts and equipped with some properties of Laplace transforms and inverse transforms, so to make things easier. So thank you guys for the lesson. Thank you.